Today we're going to explore solving quadratic equations that have complex solutions. This is a powerful technique that expands our ability to solve equations beyond those with only real number answers. Let's examine this specific quadratic equation, 3x squared minus 2x plus 1 equals 0. This particular equation will lead us to complex solutions, as we'll soon discover. Before solving, we need to identify the parts of our equation by comparing it with the standard form of a quadratic equation, x squared plus bx plus c equals 0. This standard form is the foundation for using the quadratic formula. Looking at our equation, we can identify that a equals 3, which is the coefficient of x squared. This value tells us about the opening direction and width of the parabola represented by our equation. Next, we identify that b equals negative 2, which is the coefficient of our x term. This value affects the horizontal position of the parabola's vertex. And finally, c equals 1, which is our constant term. This value determines where the parabola crosses the y-axis. Now that we've identified all our coefficients, we can apply the quadratic formula to solve this equation. The quadratic formula states that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula gives us both solutions to any quadratic equation. What makes this particular equation interesting is that when we substitute our values, the expression under the square root will be negative. This is what leads to complex solutions, where we'll need to work with the square root of a negative number, introducing the imaginary unit I. When solving quadratic equations, we first need to identify the coefficients. The standard form of a quadratic equation is a x squared plus bx plus c equals 0, where a, b, and c are constants. Let's work with this specific quadratic equation, 3x squared minus 2x plus 1 equals 0. To solve this equation, we'll first need to identify the values of a, b, and c by comparing it to the standard form. In the standard form, a is the coefficient of x squared. This is the number that multiplies the squared term, representing the steepness of the parabola when graphed. Looking at our equation, we can see that the coefficient of x squared is 3, so in this case a equals 3. The positive value tells us that the parabola opens upward. Now that we've identified a, let's move on to finding the value of b in our equation. In the standard form, b is the coefficient of the linear term x. This term affects the horizontal position of the vertex of the parabola. In our equation, we see that the coefficient